Hello students, I am Mrs. Paul NR from SGM College Karan. Today I am going to start the new topic in chemistry, transition elements and inner transition elements. This is a new topic for Maharashtra State Board. Compulsory marks 5 and marked with option are 6. Then first we are going to start the transition elements. These transition elements are also called as the D block elements. This is outline of the periodic table. In this outline of the periodic table, these groups which are at the extreme right are called as the S block elements. These groups from 13 to 18 are called as the P block elements, and these middle one groups are called as the D block elements. And the series at the bottom, two series of 14 elements are called as the F block elements. These transition elements includes in these D block elements. There are whole series of the transition elements. One series with the 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the first series. This is second series. This is third series, and this is fourth series. Thus, there are 4 series of the transition elements. Why these are also called as D block elements? Because D block elements means elements in which last electron enters in the d orbital of outermost shell, and hence which are called as transition elements. Consider this is any atom. Then in S and P block element, the last electron enters in the outermost shell. But in D block element, last electron enters in n-1 d orbital of this outermost shell, and which are called as the D block element. Then transition elements. All the transition elements are the D block elements because they are placed in this middle portion, and outermost electron enters in the n-1 d orbital where n is the valence shell or outermost shell. Then what is transition elements? Transition elements means elements which have incompletely filled or partly filled n-1 d orbital in their elementary state or the common oxidation state. Means these transition elements have incompletely filled n-1 d orbital. n-1 d orbitals incompletely filled, and hence which are the transition elements. Some elements in the D block like the zinc, cadmium, mercury, curium, which are the D block elements but not the transition elements because their n-1 d orbitals are completely filled. First, we are going to see the first series of the transition elements, which is called as the first series is called as the 3D series. Why this series is called as 3D series? Because last electron enters in the 3D orbital, hence this first series is called as the 3D series. The second series is called as the 4D series. This is called as the 5D series, and this is called as the 6D series. The elements which are present in this row or pyramid, these elements have 4 outer shells, but electron enters in the third shell, that is 3D shell. Hence, this series is called as the 3D series. Here, these elements are present in the 5th period, and hence these elements have the 5 outermost outer shells, but electron enters in the d orbital of 4th shell, hence which is called as the 4D series. Similarly, in these elements, the last electron enters in the d orbital of fifth shape. Hence it is called as the 5d series, and here the last electron enters in d orbital of sixth shape. Hence it is called as the 6d series. Thus there are 4 series. Each series is of the 10 element. The 3d series start with the first element scandium with atomic number 21 and ends with the zinc with atomic number 30. The second series start with the yttrium with atomic number 39, 21 plus 18, 39, and ends with the cadmium atomic number 48. Third series start with the atomic number 57, lanthanum, and ends with the mercury atomic number 80. Fourth series actinium, 6d series start with the actinium atomic number 89 and ends with the curium atomic number 112. These are the 4 series. Now we are going to start the first series, that's 3d series of this transition elements. 3d series is also called as the first transition series. Elements of the first transition series are the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and Zn. Atomic number of scandium is 21, titanium is 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, and zinc 30. To remember all the 3D series, serially, I prepared one sentence for it. You can prepare any funny sentence, but that element should be serial. That sentence is the science teachers invented video cassette recorder. My number है O ni Q Zn 30. That is atomic number of Zn is 30. It is considered the science, our teachers are science teachers which are invented one video cassette recorder and its number is O ni Q Zn 30. I am repeating this sentence again. Science teachers invented video cassette recorder. My number O ni Q Zn 30. Atomic number of zinc is the 30. You can prepare any funny sentence. That is, this scandium starts with the 21 and ends with the zinc 30. These are the 10 elements of the 3D series, serially 21 to 30. Now we are going to see the electronic configuration of this 3D series. Electronic configuration of 3D series or first transition series. First element is scandium. Its atomic number is 21. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Now electron enters in the 4s2 and 3d1. In short, up to 3p6, sum of the electrons is 18. 6 plus 2, 8 plus 6, 14, 16 and 18 means this is the electronic configuration of argon. Hence, in short, we can write it as the argon 3d1 4s2 or 4s2 3d1. In short, this is the expected electronic configuration of the scandium as well as the observed electronic configuration. Trick to remember this is the if atomic number is 21, electron enters in the 3d and that is the 3d1 4s2 configuration. Now configuration of other elements: scandium, titanium, vanadium, chromium, manganese. Atomic number 22, 23, 24 and 25. Its expected electronic configuration is argon 3d1 4s2. Titanium expected configuration is argon 3d2 4s2 because electron enters in the 3d orbital. Vanadium as atomic number is 23, electrons enters in d, that means the argon 3d3 4s2. Chromium expected is argon 3d4 4s2 and manganese argon 3d5 4s2. These are the expected configuration because last electron enters in the 3d and 3d orbital is filled step by step. But this is expected configuration. Observed configuration of in these elements, the observed configuration of scandium is same as the expected configuration. In case of titanium, observed configuration is same as the expected configuration. In case of argon also, observed and expected is the same. But in case of chromium, observed configuration is different. That is the argon 3d5 4s1 and the expected configuration of manganese is same as the observed configuration. And example, only in these 5 elements, configuration of chromium, observed configuration and expected configuration are the different. This is the expected, that is argon 3d4 4s2 and it is observed, that is the argon 3d5 4s2. Why it is different we will see. In case of chromium, atomic number is 24. Expected that the 3d4 4s2, but we know the half-filled and completely filled d orbitals have extra stability, and to acquire extra stability, one electron from 4s transfer to 3d orbital and electronic configuration becomes 3d5 and 4s1. In this configuration, 3d5 means which is the half-filled electron in 3d orbital is also half-filled, 4s orbital is also half-filled, and chromium acquires the extra stability, hence which has the observed configuration is 3d5 and 4s1. Then configuration of the next elements iron, which has atomic number 26. We can write only the outer electronic configuration also. That is the outer electronic configuration is 3d6 4s2. By 3d6 atomic number is 26. It is trick to remember the electronic configuration. If atomic number is 21, here 3d1 4s2. Atomic number 22, here 3d2 4s2. Now atomic number 26, here 3d6 4s2. This is trick to remember configuration. If we write this with argon, then it is called as the complete configuration. If we write without argon, then it is the outer electronic configuration of the ion. The observed configuration and expected configuration of ion is the same. That is the 3d6 4s2. Here is also 3d6 4s2. Okay, Co for cobalt. Atomic number 27. Configuration is 3d7 4s2. Observed also 3d7 4s2. Co Ni. Atomic number 28. Configuration 28 atomic number, hence configuration 3d8. 3d8 4s2. Similarly, observed also same 3d8 4s2. Q atomic number 29. Its expected configuration is 3d8 के बाद 3d9 4s2. But its observed configuration is 3d10 4s2. We will see later. Last one is the zinc. Atomic number 30, and hence at atomic number 30 3d10 4s2. Here also 3d, in copper, not 4s2 but 4s1. In zinc 3d10 4s2. In case of copper only, the observed configuration is 3d10 4s1 and expected is 3d9 4s2. Remaining all other elements have the expected and observed configuration is the same. Then why this expected configuration and observed configuration of copper is different? We will see. Copper with atomic number 29. Expected configuration, outer configuration is 3d9 4s2. But this is incompletely filled, and we know half filled and completely filled orbitals have extra stability, and hence to gain extra stability, the one electron from 4s transferred to 3d, and then it becomes 3d10 and 4s1. This 3d orbital get completely filled and 4s orbital get half filled, and this copper acquires the extra stability. Thus, the observed configuration is 3d10 4s1 instead of 3d9 4s2. This is the electronic configuration of 3d cells, and the general electronic configuration of 3d cells. Outer electronic configuration of is not complete as argon 3d electrons are filled from 1 to 10. In general configuration of 3d series is argon 3d 1 to 10 and 4s 1 to 2. Similarly, we can write This question may be asked to CET, JEE or Maharashtra State Board. That is what is the outer or general electronic configuration of 3D series, 4D series, 5D or 6D series. Or write the name and symbol of the first element of 3D series and last element of 3D series with atomic number, or 4D, 5D or 6D series. And this is the general electronic configuration of 3D series. And general electronic configuration of 4D series is also simple. आर्गन के बाद क्या आता है क्रिप्टॉन. Therefore, the electronic configuration of 4D series, that is the nearest inert gas for the 4D series, is the krypton. Therefore, its electronic configuration is krypton 4D 1 to 10. 3D के बाद 4D, 4s के बाद 5s, 5s 0 to 2. Then next 5D series, argon, krypton, xenon. Nearest inert gas of 5D series is xenon. Configuration is xenon. 5D, because here 5D electrons are filling. 5D 1 to 10, 4s, 5s and 6s 2. And last 6D series, xenon के बाद radon 6D 1 to 10 and 7s2. These are the general electronic configuration of 3D series, 4D series, 5D series and 6D series. Thus here is the electronic configuration of the transition element, general electronic configuration, and in next lecture we will see the oxidation states of the transition series. Thank you.